Hello all, welcome back to the BioRocks channel. In this video today I'm going to teach you regarding the gaseous exchange that happens in the lungs. Okay, so without any delay, I'll be starting my video by sharing my screen with you all. Yeah, so the topic that we are dealing today is going to be regarding the gaseous exchange. This is regarding the gaseous exchange. Okay, so if you remember, children, in the previous video, I was speaking about the bronchial tree in the lungs, right? How was this? It was like the trachea with the C-shaped cartilaginous rings was branching, was actually continuing as a primary. It branched into the right and left primary bronchus. Okay, and these have continued as the secondary bronchus, which we called as lobar bronchus. Okay, this was your lobar bronchus, yeah, bronchi, and later the secondary were continuing as what we call as the tertiary bronchi, which was otherwise called as septal bronchi. Okay, and I told you this tertiary can even be called as terminal bronchi. So these terminal bronchi, they divide for how many times? I told you it might be to 20 to 25 times. They just divide and they produce or provide fine branches, right? They provide fine branches, and these branches now will be called as the bronchioles. Will be called as bronchioles. Okay. Now let me take this and explain you. For instance, if this is going to be by terminal bronchi, this is my terminal bronchi. Okay, this terminal bronchi actually, as I told you, it divides further for 20 to 25 times and produces fine branches. So just think that this is a final branch of the terminal bronchi. Okay, and this terminal bronchi has lost its cartilaginous rings. Has lost the cartilaginous rings. There is no such cartilaginous rings. But remember, children, that trachea had cartilaginous rings, and these were being evident even on the primary bronchus. These were evident on the secondary bronchus. But the terminal 25th division of the bronchi, the finest branches of the terminal bronchi, okay, now they have lost, that is, they have lost their cartilaginous rings, but now what is remained is they are going to have just a smooth muscle. That's it. This is going to be the smooth muscle of the terminal bronchi. Okay, this is the smooth muscle. Now, this terminal bronchi now divides further into the fine, thin branches, which are being called as now bronchioles. These are called as bronchioles. These bronchias are so thin, and these are going to have some bleb. Bleb is nothing but outgrowth like structures. Okay, these are the bleb like structures that are found on the what we call as bronchioles. These bronchioles, since they are very, very thin and they are responsible for the diffusion of the gases or exchange of the gases, we call these bronchioles as respiratory bronchioles. We call them as respiratory bronchioles. Remember, children, as we have seen that till here, the trachea, primary bronchus, secondary bronchus, these all are the conducting airways. These all are the conducting airways. But the final terminal bronchi is also a conducting bronchi. There is no gaseous exchange happening. But as you advance towards the respiratory bronchiole, these are very, very thin, that these are going to enable for the first time the gaseous exchange. They are so very thin and they're enabling the gaseous exchange here. And their surface is having these bleb-like structures, and these individually are called as alveolus, or plurally we are going to call them as alveoli. Okay, and these are going to finally terminate with the clusters of alveoli, clusters of alveoli. So your respiratory bronchiole is terminating as bunches of alveoli, and this structure now is being called as air sacs, made up of clusters of alveoli. These are made of clusters of alveoli. So this is important, children. So till here, these are the conducting airways. Okay, these are the conducting airways. They are thicker. They're not thin enough to enable the diffusion or the gaseous exchange, but now the terminal bronchioles are so very thin that they are actually enabling the gaseous exchange, and they are terminating as these air sacs. Okay, so when we speak about, I think you people have learned about asthma. You have pathology also, right? You learn about the diseases in the different system. So asthma is one of the diseases that we learn in this chest infection, or what we call is lung infection. But where does this actually happen is going to be in the terminal bronchi level. In the terminal bronchi, what happens is there will be inflammation, okay, in the terminal bronchi. There will be inflammation during the asthma, and what happens is there will be excessive secretion of mucus in the terminal bronchi, and this mucus is going to completely plug away. They are going to obstruct the passage here. They're going to completely block away because there is a continuous mucus secretion. So there is narrow down. And secondly, what happens is along with the secretion of the mucus, the bronchi is going to contract. The bronchi, the terminal bronchi is going to get contracted. So now what happens is the lumen is going to be very, very narrow, due to which during the breathing, they are going to produce a wheeze sound, okay? And remember, children, this, in order to treat the asthma and to just widen up this particular, what we call as the lumen, we are being administered by the bronchodilator drugs, bronchodilators. What does a bronchodilator do is it's going to expand the bronchi, and it is going to once again increase the lumen of this particular bronchi. Okay, in asthma it has got what narrowed down because of the over secretion of the mucus. Just remember this. So asthma is going to be at the level of the bronchi, terminal bronchi. But when we speak about the diseases like pneumonia, and another one like emphysema, seen during the excessive smoking, okay, excessive smoking. So it's going to be emphysema. So these are being seen at the level of the air sacs. These infections are seen in the air sacs. Now coming on to children, let me take one of the, what is this? The bronchiole. So the bronchiole is thrown into blood-like structures, and finally they are ending as a cluster of air sacs, that is alveoli, called as air sac. Okay, and these are the alveolus. What is the function of the alveolus here? They are going to increase the surface area for gaseous exchange. Okay, these are going to increase the surface area for the gaseous exchange. This is the one. Now see, children, the air that we breathe in, the air that we are breathing in, which is getting in, okay, the air we breathe, what is it going to actually have is some 21% of oxygen, and we are going to have 0.03% of carbon dioxide. Okay, that is a thing that is getting in, and they are getting in into the alveoli where the gaseous exchange happens. How this is actually possible is, for example, children, if this is going to be my alveolus, or an air sac or alveoli. This is being supplied with the blood through the pulmonary artery. Okay, imagine that your pulmonary artery is carrying the blood. From where is it carrying? From the right ventricle of your heart. So what is the blood that is coming here is going to be deoxygenated blood. Is nothing but it has a very less percentage saturation of oxygen. It is almost only 75% of saturation of oxygen with the more amounts of the carbon dioxide here. Because as you know, children, the blood that is going to be transported, oxygenated blood. Oxygen will be utilized in the cellular respiration, and this blood is coming from the different parts of the body, poured into the right ventricle, and that will be the deoxygenated blood, where the oxygen was used in the cellular respiration and carbon dioxide was being added, so we call it as deoxygenated. Such blood is entering into the alveoli. So in the alveoli, what is happening as you are breathing in, every time as you're breathing in air, what is happening is the 21% of oxygen, 0.03% of carbon dioxide containing air, you're breathing in. So now what happens is, as you know already, that the pulmonary artery is going to divide as what? It is going to divide as the pulmonary capillaries. The artery is going to end as arterioles, as capillaries. So now in this, what happens is, as you know that the oxygen amount is high in the air, and the oxygen amount in the blood is going to be low. This creates what? A difference in the gradients, right? So there is a concentration gradient. There is a concentration gradient in the molecules of oxygen as well as the carbon dioxide also. As you know, here it's going to be lesser carbon dioxide, but here it is going to be more carbon dioxide. As you know that in order to equalize, there has to be a process which is being called as what? Diffusion process. So by diffusion, what happens? The oxygen molecules more from the air get diffused into the capillary blood, and the carbon dioxide which is more is going to get out into this particular air. Okay, so carbon dioxide from the capillary blood is diffusing out into the air in your alveoli, and the oxygen from the air in the alveoli is diffusing into the blood of the capillaries. Okay, let me write this for you. So what is happening is, children, from air to the top of your blood, what is happening in the pulmonary capillary? We are talking about this category now. So air has more oxygen and lesser carbon dioxide, and here it is going to be less oxygen as it is used in cellular respiration, and more carbon dioxide here. So now what happens is, by diffusion, the oxygen diffuses into the blood and the carbon dioxide diffuses out into the air. So this is a simple procedure. So remember, this pulmonary capillary, from where did it arise? It has arose from the pulmonary artery. Okay, now this pulmonary capillary is going to start up again as what? Pulmonary venules. And these pulmonary venules join together to form what? Pulmonary vein. So tell me now, the pulmonary vein blood is having what all? The highly, what you call, high concentration of oxygen has diffused in. So it is having fresh oxygen, and it is having what? The carbon dioxide diffused out. So the level of the carbon dioxide has decreased here. So lesser carbon dioxide, more amounts, and the saturation is going to be 98%. It will be saturated to 100%, children, if you're going to breathe for more times, for more 2 to 3 times. If you take deep inhalation, it will be saturated towards like 100%. So oxygen saturation will be built up, and that blood now is being termed as oxygenated blood. So this oxygenated blood in the pulmonary vein, okay, oxygenated blood in the pulmonary vein is going to be poured where? Into the left auricle. As you all know about that, the pure blood is being circulated towards the left side. So this is going to be from the left auricle, it goes into the left ventricle, and then it is going to enter into the systemic circulation, that is into the body. So it is being let into the body, and all the body is going to get back again oxygen for the cellular respiration process. Okay, I hope You understood, children? So now what I'll do is I'll try to show you the slides for you all. This will make it easier for you to imagine and what you call is understand this procedure now. Okay. So let me share my screen. Give me a moment for that. Yeah. So now I'm coming to this particular slide here. So we were speaking about what, sorry. So this was the primary bronchus, the lobar bronchus secondary, the segmental bronchus. The terminal bronchus is dividing for 20 to 25 times. And finally, the terminal bronchi or the terminal bronchiole, also you can call it as the terminal bronchi. So you can see as termed it as a terminal bronchiole, which is the last part of the conducting zone, has divided into another structure called as respiratory bronchiole. Respiratory bronchiole. And this respiratory bronchiole surface is having the bleb-like structures called as alveolus, which are increasing the area, surface area for the gaseous exchange. They are terminated into these air sacs here. And these air sacs are being supplied with the blood through the pulmonary artery. Okay, and later it is going to get out, exit out as a pulmonary, what we call as a vein. Okay, so that is going to carry the pure blood, that is the oxygenated blood now. So these are the structures that you need to understand. Okay, so if you remember, what did we have? It was a primary bronchus, the lobar secondary bronchus, next is the terminal bronchiole, terminal bronchus or bronchiole, getting branched into the respiratory bronchiole. So where do you see the asthmatic attacks are going to be in the terminal bronchiole. Okay, so the terminal bronchiole, and the terminal bronchiole we can see that it has only the smooth muscles. So these are all the smooth muscles, not the cartilaginous rings that you can see here, children, which are going to narrow down during the contraction, is going to narrow down the lumen during the asthma attacks. Okay, so and here is the thing that is going to be the air sacs, which are going to be attacked during the pneumonia, infected during pneumonia, or the emphysema disease. Okay, so this was the one that I needed to share with you all about how is a gaseous exchange enabled in the lungs, in the alveolar structures. Okay, I hope you all have understood this procedure. So if you like the video, please hit the like button, and do please comment in the comment section, subscribe my channel and share this channel with many.